All right, so for the afternoon, we're going to be focusing on a little different part of solving systems. So this morning we focused on the graphing side of it. But we're going to be looking at what happens if we have a system that doesn't graph so nicely. So again, thinking about our question here, graphing would work, but these equations that you would need to make for this, I'm not sure if we're ready to make the equations that would actually model this. But I wanted to give you a moment to kind of think about, what if I were to create an equation and try and graph the scenario? So see if you can come up with some equations that would model this situation. We would be looking for two separate equations. So pause the video, see if you can come up with two equations out of our scenario about the recreational vehicle dealership that would help us solve this by graphing. Okay, so maybe you came up with some equations, maybe you didn't, maybe you know the answer already, maybe you don't. But we're going to kind of keep bringing this question back to think about how would we go about solving this. So for right now, we don't really know how to go about solving it other than guessing and checking until we get the right answer. So we're going to start by graphing this situation. So just like we did this morning, we would start with our y-intercept. So our y-intercept in this case is at positive 3. So I'm going to graph this line in red. So starting at positive 3. And we have a slope of negative 2. That means I go down 2 and to the right 1 to get to my next point. Down 2 to the right 1. So on and so forth, all the way down the graph. And then I can kind of just follow the pattern backwards. Okay, so now that I've got that first line, I can draw and then put my arrows on the end. Again, make your lines nice and big. I don't want to see just like this teeny tiny line in the middle. Second one we'll do in blue. This has a y-intercept of 0.5. That makes it a little bit more challenging. So 0.5 would be like right there. And now our slope is at 3, meaning I have to go up 3 from here. So up 1, 2, 3 over 1. And then I can go kind of down and backwards 3. So 1, 2, 3 over 1. So our line looks something like this. Like we said this morning, our whole goal here is to come up with our solution. So our solution appears to be like right about there. But without getting really close and personal with this graph, we have no idea what the actual coordinates are. We could make a guess. To me, it looks like it'd be at like 0.25, 2.1, based off of what I'm seeing. Because it's not quite there. It doesn't look like it's quite on the 2, and it's definitely not on the 1 here, or the 0. So that's kind of in a weird spot. It's hard for me to tell. So graphing, as we can see, is not necessarily always the best option, because sometimes you're going to get a coordinate like this where it's just not nice. So what do we do when we're dealing with a set of equations that don't graph nicely? Well, that actually applies to most equations. So we're going to start talking about something called substitution. Like I said, elimination is where we're headed. But substitution is the idea that you can replace certain things with another. Think about like substitution in a sport, where you replace a person that's on the court or on the field with yourself, or they replace you by subbing in. It's the same idea. So for example, if I said y equals 12, and then I said y equals 2x plus 2, we could use substitution to replace the y with a 12, because we've said that the y and the 12 are the same. Remember, equal means the same. So what that's telling you is that if I see y, I can think 12, or I could replace it in an equation. So like I could take that 12 and plug it in right here. So my equation says 12 equals 2x plus 2. And then I could go through the process of solving. So now it's set up like something we're really familiar with, how to solve just a one variable system. or one variable equation. So I can subtract the 2, and I get 10 equals 2x, and then I can divide. And I get x is 5. But I'm not quite done. In most cases, you're going to have to go back and find our y value, but we were already given our y value. So we would write our solution as 5, 12. So the idea of substitution is really handy because it allows us to replace certain things with another. Now let's give ourselves just a slightly more complicated example. So I could have something like y equals 2x, and then I could have y equals 4x minus 4. Now it doesn't seem like we could necessarily substitute right away, but remember, y has to be the same in both equations, and since we're telling ourselves that y is the same as 2x, we can kind of cut out the middleman here and say, oh, well, I could just replace and say 2x is the same thing as 4x minus 4. And again, just like before, we're set up in a one variable system, so I can start to solve. Now I see x's on both sides, and for a lot of students that's scary, but it's not so bad. All I need to do is get all of my x's on one side of the equation, and then all my numbers on the other side. So I'm going to add the 4, so I end up with 4 equals 2x. And then I can solve for x by dividing. And I get x is 2. Now I'm not quite done because I know what x is, but now I need to go back and figure out what y is. So I'm going to take the x value I found and plug it into one of my equations. Now I could plug it into this first equation, or I could plug it into the second equation. It doesn't matter. I'm going to use the top one because to me that looks easier. So y equals 2x, or 2, times the 2 that we just found, meaning y is 4. So substitution is the idea of replacing some things with another to make the equations easier for us to solve. Because when they're set up like this, we can't actually solve an equation that has 2 different variables in it. So we need to get down to one variable in order to solve. So in the case of our example from before, the graph that we just tried to make, we're saying that both of these equations are set equal to y, meaning they're the same, which means that I can set this equal to that. So I'm going to do that. So I'm going to say negative 2x plus 3 is the same as 3x plus 0.5. Again, we can say that because they're set equal to the same thing. Since they're both set equal to y, that means I can set them equal to each other. Once I've got this set up, I can start to solve for x. So I'm going to add this 2x to the other side. So I get 3 equals 5x plus 0.5. Once we get all our x's on one side, we need to get all of our numbers on the other. So since x is on the right side, that means I'm going to move my numbers to the other side. And then I'm ready to divide to solve. And I'm going to do that math in my calculator, and I get x is 0.5. Now that I know what x is, I need to go back and plug it into one of my 2 equations to find y. Now again, it does not matter which one you choose. I tend to pick the one that looks a little bit easier to me. Now, these are about the same because I have one with a decimal and I have one with a negative, but I'm going to choose to plug it into the top equation. So I'm going to say y equals negative 2 times our 0.5, because that's what x is, plus 3. So when I do this math, I get negative 1 plus 3, which means that y is 2. So our final answer is 0.5, 2. Now if we go back and look at our original graph, we said we had to guess because we weren't sure. You couldn't really tell from this graph. And we said 0.25 and 2.1. So we were close but not quite right. So that's why it's more important for us to use an algebraic method to find our answer. So our final answer here, the correct answer, is 0.5, 2. I want you to see if you can set up this equation and solve for x. Remember, they're set equal to the same thing. They're both set equal to y. So that means we can set them equal to each other. So pause the video and see if you can solve for x. Hopefully you went through, paused the video, solved for x. So I'm going to set this up and go through it kind of quickly. So we set up our equation, solving for x. I like to make it so that I have a positive number of x's, so I'm going to go this direction instead. And I find my x value. So in case you were stuck on, whoa, what just happened? I moved all my x's from so that they're only on one side, so I moved them all from the right side to the left. I moved all my numbers to the opposite side, so from the left side to the right, and then I divided to get x. So now that I know x, I can plug it back into one of my two equations and solve for y. So I'm going to plug it into the top equation. Again, it doesn't matter which one you choose, I just tend to pick whichever one looks easier to me. So I know that x now is -2, so I'm going to plug that in. And solve. So my final answer is -2, -2. Remember, the x term goes first and the y term goes second. One more. See if you can solve this one all the way through, start to finish. Hopefully you paused and tried this one out. So if we set it up and we start to solve, I'm going to add my 3x to the other side. So I get 5x plus 17 equals -13. Subtract my 17, so I get -30, which means that x is -6. Now I'm ready to plug it in. So I'm going to plug it into the bottom one because, again, it is a little bit easier to work with those numbers since they're positives. So I get -12 plus 17, which is 5. So my final answer is -6, 5. Okay, so I want you to go and complete some practice. So go to Delta Math and complete solving systems by substitution. Again, if you're struggling or maybe it didn't make sense to you while you were watching me, you can use the videos. There's like a help video on this lesson in the upper left-hand corner of each of your assignments that might be more helpful. Otherwise, there's always the show example button on the upper right-hand corner of the assignment.